Hello and welcome back. This second lecture of the Human-Centric Building Automation course is devoted to the methodology that helps to make building automation more human-centric. Here in this lecture we are talking about methods that are based on data and IT solutions and used to make our buildings and smart cities more energy efficient. So we can say that then they belong to a field called energy informatics. Energy informatics is the field of science and research that studies and develops IT-based methods that are used to make energy production, distribution, and consumption more efficient. Buildings are usually on the consumption side, but they are also related to the distribution network. In the following slides and lectures, I will talk about it in more details. In general, we can say that by using energy informatics, we reduce energy demand. In other words, energy plus information means less required energy. In order to make any technical system do what we expect it to do, we need to control it. Here I will make a brief introduction into intelligent control, but first of all, let's see what control and what is control system, what does it mean in general. We have to have a controlled system or a plant that is any dynamic process. For example, it can be temperature in the room that is changing over time. It can be humidity in the room. It can be speed of the car or other processes. In order to control this process, we need to have a control task that is called set point. This control task or set point is given through the user interface. For example, in the car, we can choose the required speed of the car. In buildings, we have user interfaces where we can select the required temperature. And this is what we want to achieve. This is the task for the control system. In order to achieve this result, we need to know what is happening at the moment. What is the speed of the car? What is the temperature in the room? It means we have to measure the data. If we are measuring data related to the room temperature, it should also contain some trend dynamics. Is it rising or it's dropping? Because this information is all important to make decisions. All this information from requirements to measurements representing the real situation with the system come into the decision algorithm that is also called controller, and this controller makes a decision what have to be done. Do we need to heat the room or we need to cool it down? Do we need to accelerate the car or we need to brake? So the system makes decisions, and these decisions require energy. If we start heating the room, we will consume energy. So energy consumption directly depends on these decisions. As the result, we have to have the required value of the controlled parameter, for example, the required temperature. But in order to make these decisions, we need a kind of algorithm. And the smarter will be this algorithm, the more energy efficient will be the solutions. So this decision algorithm is in fact the place for artificial intelligence, for smart solutions in our control system. If we are talking about smart cities, then Buildings represent the controlled plant object and set points required temperatures, etc. Required indoor climate is given by the user through the user interface. But what is the problem with a classical control system? In fact, it's not a kind of novel technique. It exists from the last century, and each device has its own controller. Usually these controllers are even built into devices. But the main problem that all devices and each device is controlled separately. Heating is making his own decision, cooling is making his own decision, etc. And they do not talk between each other. And also they have quite limited information. We often face the situation when, for example, in the morning heating system measures that the temperature is low, some degrees below the requirement, and it starts heating with almost full power. But at 8-9 o'clock, sun starts shining, the temperature rises, outdoor temperature rises, it is getting hot, and cooling starts working, with full load. So you see, we have a double energy consumption just because two devices do not communicate between each other, and they don't take into account some trends, predictions, weather conditions. Instead of doing that, we could heat maybe a little bit in the morning because we know that after that, in any case, it will be quite hot, and we can postpone the start moment of the cooling system, and it already saves a lot of energy, but it requires using more information, and it requires controlling all the devices together within one single control framework. So in order to make a control system energy efficient, we have to take into account a lot of different information. That includes building occupancy, weather data, weather forecast, dynamics of processes inside the building. So we need some historical data. We need to take into account electricity market prices, and so on and so on. So this is huge information, and we have to process it several times per hour, usually every 15 minutes, and this is just impossible task for a human being. So a facility manager just cannot do it, and any facility manager will not go and make some small changes in order to save just some watts, even less than kilowatt. But for the technical system, it's exactly the task that they can manage. Here is one example that explains what does it mean a lot of information, a lot of data. We can consider an example of a real building. Let's say it's an average size for a commercial public building, approximately 35,000 square meters, constructed 6 years ago. And inside this building there are almost 50,000 data points. These are different information, different point sensors that can be measured. They represent temperatures in different rooms, CO2 levels, they represent the valve openings, settings for the airflow, incoming temperature, and so on and so on. So approximately 50,000 points, and almost 3,000 points are controllable. Controllable means that we can change these settings. We can increase, decrease airflows a little bit, change some temperatures, valves, etc. So each controllable component is responsible for the energy consumption, as we saw from example about intelligent control system. So we have to control each point in a smart way. And this is the task that usually cannot be performed by a human. Theoretically, all these adjustments could be made by a human. So if a human will start making all these changes, it will look like shown here. And besides the fact that theoretically all these adjustments, setting changes can be done by a human, it's not feasible for a human being. Another aspect that requires consideration is automated fault detection and diagnosis. Here is the parameter, and on the top are faults that cause alarms. So we don't want to have this type of faults that mean that something is already broken. We have to react proactively. Reactive fault detection is also not about artificial intelligence. We react when we see that something doesn't work. For example, temperature is not rising, it's cold in the room, so heating system doesn't work. So we can see it, we can feel it. On the next level are rule-based fault detections, learning-based fault detections, and fault detections based on statistics of building operations and analysis of data. And all this analysis require data and require some smartness. Here I would like to bring an example, a practical example of a fault that cannot be detected without analyzing data. And this is very simple fault. This is not critical fault, but it causes increase of energy consumption. This is about filters and clogging of the filters. So filters are getting dirty, and it means that ventilation system requires more power in order to guarantee the same amount of air passing through the filter. So the amount of air coming through the ventilation system will stay the same. You will not feel it. But the ventilation system will require much more energy. And this energy consumption, because of filter clogging, will not be visible. But when you use sensors and you put, for example, pressure sensors, measure pressure drop, it can be easily visible. And also by using this data we can apply machine learning and predict when we will need, how the pressure will change in future and when we will need to change the filter. So we will find the right moment where it makes sense to change the filter in order to avoid increasing costs, and changing makes sense. So it doesn't make sense to change filter every day, but at some moment it makes sense because the price is rising, and it can be detected by predicting the pressure. And this is how artificial intelligence and machine learning can help us to make informed decisions and save energy in practice. Thank you for your attention.